Hey, this is our video on circles, and it'll be a four-part series because then next we'll do ellipses, and then hyperbolas and parabolas, and then we'll be done for the 9 weeks. So the first thing we're going to look at is this is by far the easiest one because we've already done circles to a lot of an extent, and we're going to just look at this. We know a circle has a diameter and a radius, and we put in circumference up here and area. We're not going to really need to know those for the conics, but good review for like ACT. Okay. And we're going to talk about like the formal definition, which is the set of all points equidistant from a given point called the center. And equidistant just means equal distant. There's some formulas you need to know for the circle, and that one is the general form ax squared plus by squared plus cx plus dy plus e equals 0. So this is the general form for any conic. So a hyperbola, parabola, circle, or ellipse. And so what we want to be able to do is be able to recognize when we're given an equation, and these are numbers and variables, whether it's a circle, a hyperbola, parabola, or ellipse. And that's very easily done. You just look at the squared terms, so the two quadratic terms, and then you look at the coefficients. In a circle, the coefficients of the squareds will be the same. Same sign and everything. So they'll both be 9 or they'll both be 1, which is the most typical one. Okay, standard form, this is what we've already done. X minus h squared plus y minus k squared is equal to my radius squared. So my center, remember both of these numbers are going to be inside the argument, so they have that opposite sign relationship. So instead of it being negative h, it's going to be positive. Instead of negative k, it'll be positive k. And my radius is just going to be r, which we get from the square root of that number. A couple of these problems, you might need to do the distance formula. Remember from geometry, that is x2 minus x1 squared plus y2 minus y1 squared, all square rooted. And then we have the midpoint formula, which is just the average of your x's, two x coordinate points divided by 2, and your y coordinate points divided by 2. Okay, and now what we're going to do is just get started on the packet, which will be homework. We'll just go through and do a couple together, and then your homework is to finish those up. Okay, so the first thing that you'd want to do is label your radius and your center. I still have this one done. So, and then if you notice, I have a center at -2, 3, and a radius at 2. So what you would want to do is write those things down and then come and plug them in to the equation. So notice my radius gets squared, which is 4, and my center is going to be plugged in. Notice that they're going to change sides because they go into the argument. Okay, our next one is a center of 4, 0, and a radius of 3. And the only reason I chose this one was because you can see what happens when one of your coordinates is 0. Notice that this is x minus 4, and we don't use the 0. We just write y squared or x squared when the coordinate for the center is 0. And of course, I would square my radius and get 9. Okay, so the rest of those are for homework. Those are pretty easy. They should take you all about 10 seconds to do. The next is we're going to take the information out of an equation. So if you look at, we did number 7 and 8 in class. And notice that on number 7, both numbers are missing. So we talked about that one. It's just an x squared or a y squared at 0, 0. So this circle's at the origin. And just don't forget that this number is going to come from the square root to get the radius, which is 12. And if you notice, I didn't have 12 spots to go up and down, so I counted by 2s, and I indicated that by marking these as 12s, negative 12s, so that you can understand that I scaled it. My next number 8, remember these are opposite sides again. So 3, 1 is my circle, center, and square root of 16 is 4. So I went and graphed 3, 1 for my center, and I just went up 4, left 4, right 4, down 4, and did the best I can to draw a circle. It's not always the easiest, but it's not about the shape of your circle. It's just about whether you got the points correct. And that was like number 11. We did the same thing. So we said, well, we could have some difficult points to graph, like negative a half and a half here for my center. And then my radius was the square root of this, which is square root the numerator and denominator. So I get 3 over 2, which is 1.5. And notice it worked out pretty good. Here's my center of negative a half, and then I just go up a half and then a whole, since this radius was 1.5. So it worked out pretty good. Okay, so those are pretty easy. You can finish up working on those too. Where the main problem comes from, and I'm going to erase this. We'll go back over this one, is completing the square. So sometimes we get into general form and we need to answer the question to how do we get this back into standard form so I can get the information like the center and the radius out. And because the radius is not 5 here. Okay, so what I have to do is complete the square. Notice in the top up here, these are both perfect squares, x minus 2 squared and y plus 1 squared. And we know how to make perfect squares by creating trinomials by taking half the middle and squaring it. So what I'm going to do is I'm going to go from general form and I'm going to rewrite the equation so that my x terms match up. And note if I have an x squared plus 6x and I want to make that a perfect square trinomial. Now I'm going to write my y, have my y squared, but notice I don't have just a linear y term. There's not like this one had a 6x. I'm missing like a 2y or just whatever the y term is. That means that your y is just going to stay as y squared. It's not going to have like a y minus 2. Okay, so you don't have to complete the square on that. It has to have that linear term that comes with it. So I'm just going to complete the square once by taking half of this number. 6 divided by 3 is 2. Squared is 9. Since I added 9 on the left side, I'm going to add 9 on the right side. Write the perfect square trinomial in factored form. X minus 3 squared plus y squared equal to 34. Notice I didn't have to complete the square on that y squared because it was missing that its linear term. And so my center is just going to be negative 0, and my radius would be the square root of 34, which is approximately 5.8. And y'all can graph that on your own. Okay. The next one that I'm going to look at is this one right here, because this is probably like the most difficult one that we're going to have. And so I'm just going to erase it so I can go through it. I forgot to erase it before I started the video, but I want to start the video all over. So let me just erase it and we'll go back through it. Okay. So notice on this one, first of all, it's going to be a more difficult completing the square one because my squared terms don't have a positive 1 coefficient where I could just half the number and square it, the linear term. I have to factor out that 25 first. So I've got to remember that. So as I get this thing set up, I'm going to say 25x squared plus 10x plus blank. So I have to complete the square on the x because it's got its linear term. And now I'm going to write my y, and it also has the linear term. And I've got to complete the square twice, and then I'm going to subtract over my constant term since it was positive. And since I'm going to add some numbers to the left side, I've got to add them to the right. So the first thing that I'm going to do is factor out my 25s. And if I divide that by 25, I get 2/5. Factor out my 25 out of here. And I get 14. Get negative 10/26. Okay, now that I factored out my 25, I'm ready to do half squared. So half of 2/5 is 1/5 squared is 1/25. Half of 14 is 7 squared is 49. Don't forget, I didn't really add a 1/25 because of the distributive property. I have to multiply those together, and 25 times 1/25 is 1. And then 25 times 49 is 225, or 1225. This reduces down to 200. And I'm going to be able to factor 2x plus 1/5 squared plus y plus 7 squared. Now, if you notice, I have these 25s hanging around, which would technically not be in standard form, so I'm going to can't have a coefficient in front of my parentheses. So I'm going to divide everything by 25. And with practice, you'll get really good at completing the square. And I get 8. So my center here is going to be negative 1/5, or negative 0.2, and negative 7. And then my radius is going to be 2/3 of 2 after I reduce that. And we would just want to put that on the graph below. So the rest of these are for you to finish up on homework. Just don't forget, when you complete the square, if it's not a positive 1 squared coefficient in front of your squared, you're going to have to factor it out. Okay, I'll see you on the next video.